Hello, animators. I got a question from a fellow student about walk cycles and run cycles, and I thought it might be helpful to make a video describing how I solved this specific problem. And the problem is this. So, we know how to make a run or walk cycle. We animate the character moving forward, like so, and then we use the placement control to counter that animation. So you can see here in the translate X, we unmute this so you can see what I'm talking about. Of course, making sure that the animation is linear and animating it backwards, the opposite direction the character is moving, creates a loopable animation of the character running or walking. So that's simple enough. And if the character is moving in a straight line forward, we basically just turn this animation of the placement control off and character's moving forward. Simple enough. But what if we want the character to move along a curved path? How do we do this? So I thought I'd make a brief video that just describes how I tackled this problem for this shot. Here in the final shot, we can see this scenario poses a few challenges. The first is the obvious fact that the feet are not placed in a straight line, so we can't just copy and paste the animation. Our character's body is also moving on a curved path, but it's rotating in Y as it follows this path. We can also see as she's turning, her body is not positioned directly above her feet. So here at the apex of her turn, you can see her cog is not directly above her feet. They're on a different path. This is all further complicated by the fact that, yes, she's not only moving forward, she's moving left and right, but as we can see in the run cycle, she's moving left and right here too, alternating over each foot. So how can we set this up and plan for all of this? The first step is calculating the length of each stride or step. And that's done by simply subtracting the value of our character's cog control on the second contact pose from its value on the first. So for example, in my case, if we find the second contact pose right there, frame 342, we can see its value in Z, which is the axis forward, is 391.724. So let's copy this, paste it in our calculator, and we're going to subtract it from our cog's translate Z value on the first contact pose, so likely the first frame. That value is 201.898. Paste it in our calculator, and we get a difference of 189.826. So this is actually a necessary step in creating the counter animation of our placement control that we talked about earlier. So if we wanted to create that counter animation so that it's loopable, all we need to do is multiply this value by 2, and we get 379.652. So to create that counter animation, starting at frame 1, we have, it's actually X in this case, just the way the scene is set up, but we start at 0. And then when we go to the very end frame, we can see there's that value, 379.652. Now that we have our stride length, we need to set up the path that our character is going to run along. I set up two curves, one for the placement of the feet and another for the placement of the cog. And you can see in the overhead view that the curve on the ground is more severe, and the curve that the hips follow is more gradual as a result of the banking. Once we have those curves defined, we need to find the placement of each step. Here I used cubes that are the exact length of our stride, which we calculated earlier. And in my shot, the character is actually accelerating to full speed and then decelerating towards the end. So you'll notice that the cube scale is modulated accordingly. So you can use these curves just as a guide to place your feet and your cog, or you can take it one step further and add more control. I created a bank control that animates along the curve so I could get a sense of the bank and make adjustments. Breaking this down further, we can see there's the bank control that follows the curve. There's an up-down control, which only animates in translate Y. And then there's something I called the cog parent, which is what our character's cog is going to be constrained to while it's animating along this path. So let's set this up from scratch. To get our bank control to animate along our path, we first select the control, then the motion path, and we go to Constrain, Motion Paths, Attach to Motion Path. We'll open the dialog box. Time range set to time slider is fine, as we can adjust this later. Front axis in my case is X. In yours it may be Z depending on your setup. Up axis Y is fine, and everything else looks good. Click Attach. And we can see the control is already animating along the path. This animation actually lives on the curve, and the outputs here you'll see motion path, and it's this U value here. So this is where we may want to say, oh, our character is, going fast in the beginning and then slowing down. Just for demonstration, let's simplify this and just make this linear. So the bank control is going along the path and it's rotating in Y, which is good. The problem is that it's not tilting. It's not banking as the character turns. So when we go to the channel box, we can see there's a problem. These controls are constrained, so we can't animate them. And we could solve this by nesting a control underneath, or you can do what I did, and that's to bake this animation, and you can get control of those attributes back. So to do this, we select our bank control, and we go to Key, Bake Simulation, and let's look at these options. Everything here, time range, time slider is fine, is good. This is the main setting you might want to change. In my case, my run cycle is on 1s, so I might sample by 1, but you might be animating on 2s or on 4s, doing your blocking. So this is where you're going to change how frequently there's going to be keyframes. Let's do 2s and bake this. So now, if we select our bank control, we can see that the constraint is gone, and we've regained access to our animation. So if we look at our rotations, we can see there is a problem here. There's a big bump, and it looks like we need an Euler filter to correct this. So let's select all of our rotation attributes and go to curves and click Euler filter. And in most cases that will fix the problem. Let's now constrain our character to this bank control. So we can do this by first selecting the cog parent and then our character's cog and going to constrain parent. Let's reset these settings. Since our cog is not positioned exactly on the cog parent's pivot, we can just uncheck maintain offset and that will snap her cog into the correct position. Let's add this. So now our character is following the motion path. We can now start to animate this bank as she turns left and right. So that's going to be in our bank control on the rotate X. So let's go to a point where she's turning sharply. Frame 104 should work. And kind of lining this up. I set my bank control to just have a vertical curve going down so I could kind of see where her hips are aimed. As she's going along, I generally just kind of kept it aimed at the ground curve, but it's also just going to be based on your feeling of the animation. And you may want to have less keyframes as you're blocking this out, but for demonstration, this should be fine. And as you can see in the overhead view, when she gets to frame 114, she's going to be straight up and down. So this is sort of how you can adjust the bank as she's running along the curve. So now we want to attach our character to this rig that we've created. Before we do that though, we want to pose them in their first contact pose that starts the run or walk cycle. So for me, that's my character's left foot contact pose. The other thing we want to do is we want to address this problem that we talked about earlier. And that is that in our run cycle, we can see the cog control is moving left and right, it's moving up and down, and it's rotating in X. So we've already anticipated this, and that's why we've set up the cog parent control, which basically is an exact copy of what the cog is going to do in the run cycle, but it's nested within the up and down control that accounts for the variable distance between these two curves, and the bank control that follows along our motion path. So all we need to do is select our cog control, go to the first frame of our run cycle so we can see left foot contact pose. And the only attributes we need are the translate X, the translate Y, and the rotate X. And we can just select the entire run cycle, copy these frames, go back to our first contact pose, which for me is frame 102, and select our cog parent. Here we can paste that animation. And you can see it will more or less match where our cog is positioned. And we can just continue to paste this throughout our motion path. And now we can constrain our character to this rig we've created. And that's just done simply by selecting the cog parent and then selecting your cog control on your character and going to constrain parent. Let's reset these settings. So we can see that our character is not positioned on the pivot of our cog parent. So we can correct this by just unchecking maintain offset, and that will snap your character into position. Once we add this constraint, our character is now following along our motion path and banking as she turns left and right. So we want to start blocking in this run animation, but I wanted to give you a preview of how I set this up. So I have my contact pose, and then I go into a passing pose. Then I go into the apex where my character's at their highest point, and then into the next contact pose. And because my run cycle is 10 frames total, each stride is 5 frames, which leaves me with an awkward spacing in the keyframes here where I have a part that's on ones, then 2, 2, 1, 2, 2, 1, 2, 2, 1. Most likely yours is on 2s, so you probably won't have this problem, but if it is, then you might be able to use this timing. So let's set this up from scratch. We've got our character moving along the motion path, but we need to bring in all the other controls and start blocking in this animation. So let's select those controls by opening up our picker. In my case, I can just click all body and face, but I want to exclude this placement control as that has the counter animation from the run cycle, which moves backwards and makes the character appear to be running in place. We can also get rid of the cog itself because that animation exists on this cog parent. So then we can go to the first frame of our run cycle, which doesn't look right because she's parented to the cog parent, but that's okay. We don't need to see it. And copy, select all of these frames for your entire run cycle, and right click, copy, go to the first frame of our animation, which in my case is 102, right click, paste. So everything came over, but our feet are not in the right place. So this is where the stride length blocks come in handy. So the first contact pose is our left foot, and we know it's going to be at the end of that first stride. The TY, swivel, and within the foot control, the bank should all be maintained from our run cycle animation. Before we go any further, since I'm just blocking this out right now, I don't need everything to be on ones. So let's reselect all of our controls and get rid of these extra frames. So it was 2, so I can cut this. Then it's on ones. Then it's 2. Cut this. 2. Cut this. Ones. Then 2. Cut this. So back to the beginning. We just need to adjust our feet. And for the foot that's in the contact pose, for the one on the ground, we pretty much just follow our blocks. For this other foot, we're sort of flying blind. So I just brought in a reference of my run cycle and then just visually matched this. You can see that it's further back. Maybe rotate it a little bit more Y. And again, you shouldn't need to translate it in Y. You should just need to do X, Z, and rotate Y. And get it roughly into place. Because of the bank, you may need to go in to whatever controls your foot bank and your character and adjust that. Because we can see the foot is further to the right than it would be if the character was running straight. So that knee is kind of getting into the space of our other leg. So we may want to just make slight adjustments either to the bank, or we could do it in the swivel. And this is just in the blocking. But this lays the groundwork for the animation later, so you want to get this looking good. So next we have our passing pose. Our left foot should still be in the same place, and if I had animate, I could just blend to neighbor, but since I don't, I can just snap these to where they were in the previous frame. And again, it should just be TX, TZ, and rotate Y. You've already done most of the work animating all the other attributes, and you can keep 90% of that, if not more. And this will be in a new place, so we don't need the graph editor. And I'm just matching visually my reference. You can see it's crossing over. This goes further in. So we can definitely see that problem here. The knee is really protruding into the other leg. So this is when it's good to adjust the bank. It's pretty much correlated exactly with how much the body is banking. And that's represented in this bank control here. So as you're blocking this in, you can continue to make adjustments to this and just fine tune it as you're going along. Let's go to our next pose. This is the apex. So again, our left foot. We'll just bring this back to where it was. Kind of snaps into place there. Bring that back. Bring the rotate back. And you can see she's lunging off. This brings up why we created this up and down control. As she starts to turn, the distance between the hip level curve and the ground level curve is more than it would be if she was just running in a straight line. So you can use this up down control just to translate Y, and you can modulate that distance. So maybe she's lunging too far. But you can just kind of hone that in the animation as you're blocking it. So our left foot is in place. Our right foot needs to be adjusted. Again, just matching the reference. rotate Y. We definitely need to adjust the bank. We're having that same problem with the knee. But there, starting to look like our reference. And next pose is our contact pose. So we know it's the right height. We just need to bring it into place. Rotate it in Y. Looks like we've got some bank. Might be good to adjust. This foot has lifted off the ground. Get that roughly into place. Rotate it in Y. It's much further back. This should be just the opposite of our very first pose. Select what controls the bank. This is pretty much attached to what the bank control is doing. Just look at it from all angles. And just keep going. And as we're blocking, we can use these controls that we set up to help deal with some of the problems that running along a curve presents. So here at the sharpest point of her turn, her cog is further away than the ground curve than it would be if she was running in a straight line. So we can adjust the TY of this, get her in the right position. You want to make these keyframes on this up-down control minimal, because it's really just to compensate for the distance between the two curves. It is not the same as the TY for the body that kind of controls the weight of the character as she's running or walking. Same with this bank control. We can continue to adjust this. You can see how that affects our back leg. So we can adjust this as we're blocking too. And once we are happy with our blocking for our shot, it's time to do the same thing that we did with the bank control, where we bake the animation, because we don't want to be constrained to this rig that we've created. We've gotten all the utility out of it that we need at this point, and it's time to get more fine-tuned control before we move into spline. So to do that, we just select our cog and go Key, Bake Simulation. Let's open the dialog box. Reset these settings. As we've discussed, my run cycle, each stride is 5 frames long, so that leaves me with an odd number. So unfortunately I need to sample by 2, but if you're animating on 2s or blocking on 2s, then most likely you'll set this to 2. But let's set this to 1 and bake. And now we are no longer constrained to the curve, so we can move into the spline process. Once we're happy with our blocking, we need to fill in the gaps, if there are any, in our keyframes before we move on to spline. So we can once again select all of our controls. We want to again exclude the placement control and exclude the cog control, but we also don't want the feet because we don't want the animation that we've already blocked in to be messed up by the translate values that are in the run cycle. So let's go to these run cycle frames, select all those, right click, copy, go to the first frame of our animation, and paste. And now we've filled in the gaps on all the other controls. For the feet, what we can do and what we can preserve is the translate Y. Everything else is going to be compromised by the run cycle, and we're going to have to adjust those values manually for each frame. So we can select both feet. We can make sure that only translate Y is selected in the channel box. Go to the first frame of our run cycle, select all of them, copy it, go to the first frame of our animation, and paste. Then we just need to adjust the in-between frames that we haven't accounted for. So deselect translate Y by just clicking away, and just adjust this manually until it's in the right place. You may also need to adjust the bank. And make sure to keyframe all of the attributes. You can move forward to the next frame. We already have that situated in our passing pose, so the next frame we need to adjust. We already have, as it's the apex of our run, and this frame needs to be adjusted. And we can just match our reference. Once again, we don't need to adjust the translate Y. It's already in there from the run cycle. But the bank, you likely will need to adjust. Also the rotate Y. And you just keep moving forward like this. We also need to adjust the position of this foot, catch it back up with the body. It looks like everything else is correct. So that's how we copy the animation from our run cycle onto our motion path animation. From there, it's the same as any other splining process. You're just going to want to take small bits at a time and make adjustments, starting of course with the cog control. The most important attributes, you can kind of see my curves, they're not an exact copy of each other. They change as she's going around more severe turns. So while you can copy and paste the profile of the curves, you will need to manually adjust the actual amounts. They kind of will always have the same acceleration and deceleration, but the amplitude will change. And you'll have to manually adjust, obviously, the rotation of the head, bring in your acting choices, and work on this like any other animation. The run cycle is just a starting point, really. But that was my setup for getting my run cycle onto a curved path. It may not be the most straightforward way to do this, but it's an approach that I think gives you a lot of control without having to sort of tediously recreate your run cycle in the blocking and in the spline phase.